I don't want it separated from everything else, so we can just focus on this. All right, first thing that you should notice when you're doing a problem like this is that negative leading coefficients, okay? Here, let me highlight it. So right away, you can see that this leading coefficient, it is always going to go in order like that, to the highest power to the lowest. It's negative. So that means as I go left to right, should I be going down or up? Down. Negative is down. Okay, so right now we should, you know, in your head, you can picture that from left to right, it should be going down. Next thing I want you to notice is that it's to the third. Okay, it's an odd function. That means a rough, very, very rough sketch of this. Don't write this down yet because I'm just showing you an example. It should have 2 turns and it should be pointed down like this. Okay, that's the sketch so far, but I'm just showing you that for purposes of where your understanding is right now. You should be noticing that it's going down, going this way, and it's to the third. So there's going to be 2 turns, 1 turn here and another turn here, and it's x to the third. If it was x squared and it was negative, they'd both be pointing down. Okay, this one, there's 2 of them though. But again, don't write that down because we're not done yet. That's the first thing that you need to look at is the whatchamacallit, the negative, the coefficient, the sign of the coefficient, it's negative, so it's going down, and then it's the third, so there's going to be 2 turns, at least. It could be 1 turn, but there could be 2. At the max, the most, okay? All right, the next thing we need to do is figure out what the X and Y intercepts are, okay? So right now, actually, I'm going to write this down. So it should be, so left to right, it's going to be going down. Okay, and then there should be at the most 2 turns. Oops. Just writing notes from, and I got all of that just from looking at that first thing. It's negative, so left to right it's going down, and then there's 2 turns. Okay, I feel like I keep repeating myself, sorry. Okay, we need to figure out the X and Y intercepts, so we need to actually solve this equal to 0. But the easiest way to solve this for 0 is by factoring it. So you are going to have to factor this whole thing out. Now it looks really complicated, but it actually is not. Okay. What is a common factor between all 3 of these? Does anybody know? Each one of them has a certain, yes, x. Okay. And since it's a negative x and I don't like negatives, I'm actually going to pull the negative out. And then you're going to end up with x squared minus 4x plus 4. Okay, so if I distribute that negative x into all of these, it should get where you started. Okay, so we're just factoring this out bit by bit. This should be a review of intermediate algebra, but again, I'm assuming that a lot of people forgot that stuff because of all the chaos that's happening. So if I do go too fast on something, please chime in. Okay, and you can, it's really easy to chime in too, because you can just be like, dude, what did you do on the orange step? Like that way I'll know what you're talking about. So everything is color coded, unless you're colorblind. And if you are, I'm sorry. I usually ask that in the beginning of the year, but I forgot to do it.
Plus 4.
Yeah.
It's plus 4 now because you took out the negative.
Exactly. Yep. Exactly. And a good way of doing this too is like check your work. Like if I distributed this, would I get negative x cubed? Yep. Check it here. Would you get positive 4x squared? Yep. And then would you get negative 4x if it did that? So always check your work. Assume you're wrong. Try to figure out, prove it to yourself that you're right, which is just code for check your work. All right, this thing right here, could factor, okay? There are 2 ways, well, there's more than 2 ways, but there's 2 basic ways that you can factor this. You can, 1, find the solution for it. So if you use quadratic formula, figure out the solutions and write it in factored form from there. Or if you wanted, you could just factor it by, the old school way of just going, well, what 2 numbers multiply to get this and add to get negative 4? Okay. I don't care which way you do it. You're going to always get the same answer either way. I'm going to show you both ways. So the factored form of this is what 2 numbers multiply to get this and add to get this. Well, it'd be -2 and -2. Okay. If you multiply them, you get 4. If you add them, you get -4. So if you wanted, since they're both -2, you can rewrite that quadratic right there. So I'm going to rewrite this whole thing in factored form, -x, and you can write it as x plus, oops, not x plus 2, that's embarrassing, x minus 2 times x minus 2. Okay. Everything is a linear factor in there. Okay. It's just x's, there's no squareds or anything like that. Everything's a linear thing. Linear, linear, linear. That's what you want. Because when it's like that, it's easy to solve. Now, say you didn't want to do it that way. Say what you could do is you can use quadratic formula. So what I'm going to do is, what I'm highlighting in green right here, this thing, I'm going to use quadratic formula on it. So it's going to be x is equal to negative b, which is negative negative 4, so 4, plus or minus b squared, which is 16, minus 4ac. 4 times 1 times 4 is 16. And then we're dividing this by 2a, which a is 1, so we're just dividing this by 2. This simplifies, this is 0. So you have 4 over 2, 4 plus or minus 0 over 2, which is just 2. So if your solution is 2, that means your factor is x minus 2. Okay? But you'll notice that you did 4 plus or minus 0. So that plus or minus 0, that means there's actually 2 of them. So you would have to square it. Okay? Another way of thinking about it is you couldn't just have one of these. You need 2 of them because you need it to be squared. If you just had one, it would be linear. Either way, they both get you the same. This is multiplicity 2. They both get you the same thing. So you could choose which ones you want to work on. It doesn't matter if you want to do factoring the old school way or if you want to do it with quadratic formula. It does not matter. Now we have everything that we need to graph this, believe it or not. Okay. These, each one of these, if you set it equal to 0 and solve, will get you where the x-intercepts are. So this first one, if you set negative x equal to 0 and solved it, x is equal to what? Somebody just chime in. Anybody?
0.
0. Okay, so then we know that right here is an x-intercept. Oh, I think someone wrote it in the chat. I just heard something go off. Nope, I lied. Okay, so we have 1. Now you don't really need to write that down. I did it anyway. X minus 2, where's x minus 2 equal to 0? At 2. So I'm just going to say this is 2, and then we have a point right there. Okay, so now we have both x-intercepts. We also have the y-intercept as well right here because it goes through the y-intercept, so we don't have to even worry about calculating that later. So we have those 3 things, or those 2 things right there. Okay, we have 2. Let's do this in black. We have 2 and 0 as the 2. Also, just to kind of review the stuff that we went over yesterday, if you notice there are 2 x minus 2s, that means the multiplicity is 2 because they're twins. So because of that, that is technically 3 solutions. We have 1 solution, 2 solutions, 3. And that is how many we're supposed to have because the power is 3. So that is one thing to look out for. Now, if it's a multiplicity of 2, what is happening at 2 then? Do you remember from yesterday's lesson with multiplicity? If it's even, what happens? It bounces, thank you. Now, it bounces either this way or this way. Well, you have to figure out which way it is. And this is where it gets a little tricky. Well, remember before I said the graph should look like this? It should look something like this. Well, that means the bounce should be there. So really the graph should look like this. It should bounce here. That way it goes down to the right. If you don't bounce that way, you'd be going up. And you can't go up on this because remember, it's left to right, it's going down. You have to go down on that. And you have to connect the dots here to have something like that. And that's your final answer. Okay, so how I would grade this is I would look for the bounce. I would look for if it's going down over here. And I would look for the turns. There's 2 turns. Okay, and I would look for the y-intercept. So I'm looking for 4 things. It's going in the negative direction. It's got a bounce. It's going through 2 and 0, which is the x-intercepts. And then the y-intercept is 0. So it's 4 things. And again, I would write this in your notes as we're doing this because you're going to see a problem just like it. And you can follow those same steps. For the quizzes, for the test, trying to be lenient here. Yes?
Why wouldn't 2 be on the other side? Everything's been negative.
Okay, but if you put negative 2 into this, you wouldn't get 0. Like 2 minus 2 is 0. You want this to be equal to 0 for the x-intercepts. because the y is 0 here. Oops, I'm sorry. People at home are like, what are you pointing at? So the x-intercepts are where the y is 0, because as you can see right here, all the y's are 0 of where I highlighted. So essentially what you're doing is setting this equal to 0. And x minus 2, if you put negative 2 in there, negative 2 minus 2 is negative 4. We want 0, so that's why it's a 2. It's like the opposite. It's kind of annoying, but if you write it down, though, hopefully you won't make the mistake on a test, right? There. Good question, though. Okay, any other questions on this? I went over multiplicity. I went over the bounce. I went over the fact that it's got a negative leading coefficient, so as you go from left to right, it should be going down. It's got 2 turns, which remember, the number of turns plus 1 tells you the degree, the lowest degree possible. All right, let's go to the next one. Separate this out a little bit. There we go. Okay, the next one is we're going to be graphing this thing here. Let's make the XY plane. And by the way, the graph is not exact. Again, it's a sketch. If I actually graphed that out with a graphing calculator, it would look something like that, but it wouldn't look 100% like that. Okay, I should probably check it. Yep, it works. Yep, okay, cool. And just to kind of show you, I'll load up some Desmos real quick to show you this. Whoops. So y equals negative x to the third. Is it minus 4x? I don't remember. Oh, plus 4x squared. 4x squared minus 4. Okay. Oops. Minus 4x. Jeez, that's embarrassing. Okay, and you can see it more or less looks the same. Again, it's just a sketch. It's not meant to be like, this is a machine or computer basically graphing this out versus, a human. But I was looking for that, the bounce, and the fact that it's left to right going down, and the turns. Okay. All right, number 12, same thing here. It's already factored, which is kind of nice. We don't have to do anything with that. But first thing we should notice is that let's actually distribute this out. Maybe that's a good idea. Distribute this out. You're going to get x to the third minus 4x squared. So essentially what we should, essentially what we should have for this is something that has maybe 2 turns, maybe 1, but at the most it would have 2 turns for this. So it kind of gives us an idea. It also shows the leading coefficient is positive. So that means that going from left to right, it should be going up. Okay, so if I had to draw this right now, based on the information, even though we're not done, it should look something like this, around something like that, possibly. And that's taking into account that it's x to the third. So that's why there's 2 turns, 1, 2, and then it's going up left to right. Okay. Don't just draw that though, because you would only get half credit on that because you'd have the left to right correct and the number of turns correct, but you didn't do any of the X and Y intercepts. So that's what we're going to do next. We good so far? Okay. So let's start with the original because it's already factored, and we're going to find the X-intercepts. To find the X-intercepts, you just set this equal to 0, and you solve. Okay. So that means you set x squared equal to 0. And you set x minus 4 equal to 0. So I set each of their factors equal to 0. Now, the reason you do that is because if this, what I'm highlighting right here, if this is 0, then you're automatically going to get a 0. It doesn't matter what x minus 4 is. If it's 0 times anything, it's 0. Okay, in the same respect, if this was 0, it wouldn't matter what x squared is. You're still going to get 0. So that's why we're setting each of the factors equal to 0. This one right here, it's x squared equals 0. So you're going to get x is equal to the square root plus or minus. Now, if you do plus or minus on this, that kind of tells you that it's, like I said before, the plus or minus 0 tells you that really it's just going to be multiplicity 2. Okay, because you have plus or minus on this. And to kind of show you this, let me rewrite it. So if you do plus or minus here with this square root and this square root here, plus or minus 0 is the same thing. Every other number, if you do plus or minus it, it's different. Plus or minus 1, that's negative 1, positive 1. Plus or minus 2, positive 1, positive 2, negative 2. But 0, it's 0. It's in between, so you have to do that multiplicity for it. The other one here, if you add 4 to the other side, you get x equals 4. It's multiplicity 1. There's no plus or minus. There's no square root. There's nothing like that. Okay. Another way you can look at it is just looking at the power. This is 2. You should have 2 answers out of this, but there's only 1. That means it's multiplicity 2. This one is x to the first. There's only 1 answer, 4. Now you can write multiplicity 1 if you want, but it's just kind of redundant. Kind of like writing 1x. You just write x. So you don't need to worry about multiplicity 1. But do write multiplicity 2 because you get credit for doing the multiplicities. So that means there's 2 answers here and 1 answer here, which we should have, like we said before, 3 answers because it's x to the third. Cool, that means we found all the x-intercepts. So let's graph them. Here we go. 0. And let's just say this is 4 over here. 4. I'm graphing that. Okay. Now, if you remember before, I said the graph should look something like this. Okay. But it needs to be a little bit more exact because it needs to go through these dots. Okay. You need to connect the dots. Also, there is a multiplicity of 2 at 0. So what should happen at 0? Multiplicity 2, it's an bounce. So we're doing a bounce here. And then it goes through here, and then it still follows that same pattern. There's 2 turns, which you should have, and there's 3 solutions. And we have the x-intercept as well, because it's 0 again. That makes it kind of easy, and that's the answer. Are there any questions on this? All right, just for fun, let's graph it. So y equals x squared times, times x minus 4. It doesn't look like ours, but that's because I had to zoom out. It crosses at 4 here, it bounces at 0. Obviously, this looks way better than our graph. Well, my graph, maybe other people wrote graphs really awesome, but there you go. Now, this is already in factored form, which is awesome. I'm not going to try to expand that out. I'm not going to try to distribute that. It would take you 1.5 years to do. Okay? But the one thing I do want you to notice is that this is an x to the first right here. Let me zoom in. This is an x to the first right here, and it's squared. So that means overall, that's going to be x squared. This one's going to be x to the 5th. So you're going to have an x squared times x to the 5th. That means you should have x to the 7th. So that means you should have 7 answers on this. Okay, I do want you to see that. You do not need to expand this out because it would take you 1 year. If you try to like distribute all of this out, the leading coefficient would have an x to the 7th power. Okay, but I just want you to kind of see it by looking at it. You can just go, oh, there's an x and it's squared, that's x squared, and then you're multiplying it by x to the 5th. So if you think about it this way, x squared times x to the 5th is going to be x to the 7th. Now they make calculators that do this. Okay, this is like Google on steroids, this website. You might have heard of it already. It's called Wolfram Alpha. But what you can do is you can write in x minus 1. Oops, why is it not writing? Oops. X minus 1 to the squared, yep, squared times x minus 5, oops, x minus 3 to the 5th. And hit enter. and it literally works it all out for you. So there it is. It actually shows what the graph looks like. And then if you keep going down here, it does the expanded form. This is the full version. Here, let me blow this up. This is the full version of if you multiplied it all out. It would take you 1.5 years to do. Okay, it would even take me a long time to do it. I'm a teacher. Okay, way too long to do. We're not going to worry about that. It's already in factored form, so we're going to just keep it in factored form. But the main thing I want you to see is if you throw that in the calculator, you get x to the 7th, which is what I got here by just looking at the x's. I don't care about all the other stuff. All that other stuff is meaningless to me. Huge numbers. Okay. So since it's x to the 7th and it's positive x to the 7th, that means it's an odd power. That means you know that the graph could look something like this. Okay? The graph could look something like this to the 7th. So that means it's 6 turns. So it's 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5, 6. Okay, so it could look something like this. It could be that many turns, or it could be less. But either way, the main thing we need to see here is that it's going up as we go left to right, because there's no negatives in there. There's no negative in front. If there was a negative in front, then we wouldn't be able to do that. Okay, but we're going to get rid of this sketch. Ignore this. We're going to go into better detail here. Okay, here we go. So right now we know the direction it's pointing and then how many turns it could possibly have. Let's try to solve this equal to 0 and find the x-intercepts. Okay. Well, if you remember, what you do for setting it equal to 0 is you set each of the factors equal to 0. So we're going to set x minus 1 squared equal to 0. And you should get 2 answers to that because the power is 2. And we're going to set x minus 3 to the 5th power equal to 0, which you should get 5 answers because it's a fifth power up there. Okay, do not try to expand these out. You should just be able to see x minus 1. I could just plug in 1 and it's 0. So I'm going to plug a 1 in there. Now it is squared, so make sure you do multiplicity 2. The next one, it's going to be x equals 3. You can kind of just see that. 3 minus 3 is 0. But it's to the 5th power, and you only have 1 answer, so that means you have to say multiplicity 5, which is awesome because now we have 7 answers. We have 2 1s and 5 3s. Which one's going to have the bounce between the 1 or the 3? Or is it both of them? Which one's going to have the bounce? Well, only the even multiplicity is going to have the bounce. Just the 1. And the 5, the 3 is just going to go, it's just going to go through it there. So it's going to cross it. So if you didn't know that already, even multiplicities, it bounces. Even. So 2, 4, 6, 8, so on, it bounces. And so let's try to graph this out now. We have 1. So here's 1. And then the other one's going to be 3. This is not to scale, although it kind of looks like it's decently to scale, but not really. All right. Well, one of the solutions is here, and the other solution is here. Okay. Now, as we talked about before, you should be going up as you go left to right at the very end of it. So we have to take that into account. We did say that there was a bounce right here. So we're going to bounce here, and it's going to go this way. It cannot go up again, because if it does, it would knock into this. Okay. I guess it could do this, but I'm not going to worry about that because we don't actually know if it does that or not. So I'm just going to bounce at 1. And then when it gets to the 3, it kind of just like flatlines for a little bit and then comes up like this. Okay. Other than that, we really don't know much else about this problem. Zoom in here. So this first one, can someone tell me what are some of the zeros? If I set this equal to 0 here, what are the x values that would cause this to be 0? For example, what would I put right here to make this a 0? -1. Okay, it's a multiplicity of 1 because there's a 1 right there, so I don't need to worry about that. You divide both sides by 2, and you get 3 halves. So that's another 0 here, 3 halves. But this one's squared, so then you would have to write multiplicity 2. And then it says state whether it crosses it or if it touches it. So you can just say x equals -1, it crosses. And then you can say x equals 3/2, because it's a multiplicity of 2, it bounces. X equals 3/2 bounces. And that's your answer for that one. Okay, you're looking for the solutions, the zeros, you're looking for the multiplicity, and you're looking for whether it crosses or bounces. I'm going to highlight the answers here. Okay, the next one here, we're going to set this equal to 0, find the zeros again. So we have this one right here, it's going to be x equals 2, and it's got a multiplicity of 3. This one right here, it's x equals -4, and it's got a multiplicity of 4. Okay, so then if we were doing the crossing thing, whether it crosses or not, you would say at x equals 2, it crosses because it's to the third, it's a third multiplicity 3. And then, all right, so the only thing I went over when I lost connection right there was the answers here. So if you look at the answers for 14C, that's all of them right there. All right, this first one, you have to factor it because it's not in factored form. It's just going to help figure out what this graph's going to look like, where the x-intercepts are, which is what we're looking for. We don't actually have to do the graph on this one. I totally forgot. So whenever this happens, what you want to do is factor by grouping. So do something like this. You should have remembered this from intermediate algebra, from previous algebra classes. Let me move E out of the way. You have to do the common factor between these two, which is x squared, because there's an x squared in the x cubed, and there's an x squared in that. And then if you factor that out, you'll just get x plus 3. Okay, I'm going to try to color code this. So this orange one goes with this orange work here. Okay. We'll do yellow for the other one. Okay. Whenever there's a negative like that, always factor it out. So I'm going to factor out a -1, and then you're going to get x plus 3. Okay, and then this is, again, linking with that other stuff there. Now, if you notice, there is a common factor here of x plus 3 and x plus 3. So what I'm going to do is factor out the x plus 3 by putting it in front, and then whatever's left, which is going to be the x squared, and the -1, I'm going to put that there. Okay. Next, you have difference of squares right here. So you can factor that as well. So it's going to be x plus 3 times x plus 1 times x minus 1. Okay, so this thing right here that I just highlighted is equal to this right here. And now we're in full factored form, so we can solve this. So if you notice, the other ones that we did, they just kind of started in factored form. This one does not, or was not, so we had to make it in factored form. So now we can find those zeros. All right, it's not very exciting on this one because there's no multiplicities. So you're just going to end up with -3 and then positive and -1. Okay, and you don't have to write it like that if you don't want. You can write 1 and -1, doesn't matter. Yeah, their multiplicities are all 1, so I'm not going to write anything with that, and they all cross the x-axis. So that's the answer for this one. Okay, questions on this one? Yes.
How do you know if they cross or bounce?
Oh, the bounce is if it's an even multiplicity. So if it's multiplicity 2, 4, 6, 8, and so on. And make sure you write that in your notes. Even multiplicity bounces. Everything else crosses. Odd crosses, even bounces. All right, last one. Actually, no, we still got 2 more after that. It's okay. So let's break this one down here. We're setting this equal to 0. It's easier to factor this out, so we're going to solve. So we're going to factor this out. You're going to end up with x squared plus 4x minus, or I'm sorry, plus 4. Oops, and that means this is negative. Is equal to 0. This is actually the exact same factoring that we had for the other one. So we actually solved this problem already, essentially. So it's going to be negative x squared, and then this factors to x minus 2 times x minus 2 equals 0. which means your answers are going to be x equals 0, multiplicity 1, and then there's a 2 here and a 2 here, so there's two 2's, so you have to do multiplicity 2. Okay, this one bounces, and this one, 0 crosses. And that's it for that one. Okay. And the last one, it says sketch a graph of an odd function with zeros at those values. Let's see here, where do I have room? Okay, odd function, we don't really need to worry about that so much for this one. I probably should have gotten rid of that because it doesn't really matter. So first thing I'm going to do is make my XY coordinate plane, and it says the zeros are at 2. Okay, 2, -1. So I'm going to write this out here. Here's -1. Here's 2, and a positive leading coefficient. Okay, so if it's a multiplicity of 2 at 2, that means it should bounce at 2, and it's going to cross at 1. So it's going to bounce here and go up, and then it's going to do that here, and that's basically it. So I wanted an odd function. I'm assuming that's why I wanted it to be x to the third. That's what this is essentially. If you wanted to, you could have like done this, but then there was another solution there. Doesn't really matter. I guess you could have also just made it like that, but again, you don't really need to do that. Okay, so that's A. B, it's got a multiplicity of 4 for -1, so that means it's going to bounce there. Okay, so here's -1, it's going to bounce there, and then -3 is over here. Negative leading coefficient, so that means it should be going down when you go left to right. This one's going to bounce, and the only way that you can make it go down to left to right is to bounce there. So we're going to graph that point, and then it's going to go up here and do that. And that's basically the answer for those.